Hey y'all, welcome to the 9.2 introduction video. This is just the for example column on the front page. The examples on the rest of the pages will be on a separate video file. So as we start working on these trig identities, we want to remember a little bit of algebra in order to help us out with this. So there are certain things we can do with the trig functions, okay? We want to pick a side to start with and only work on that one side, okay? Then it's very helpful to start with the more complicated side and try to simplify it so that it equals the less complicated side, okay? So some things you can do. We already worked on this a little bit in 9.1. We converted everything to sine and cosine. Those are our defaults. Things will divide out nicely if you can get them all into sines and cosines. Some other things you can do. If you have two terms and you only want one, you can get a common denominator to add or subtract fractions, or you can factor something out of it. Okay, common denominator, adding and subtracting fractions. Let's look at this example. 2 over 3 minus 4 over x. That common denominator, lowest common denominator, needs to be 3x, multiplying the two denominators we have together. So we need to multiply this first fraction by x over x. And we need to multiply this second fraction by 3 over 3. Then multiply. 2 times x gives us 2x, okay? Minus 4 times 3 is 12. And we're dividing all of that by our common denominator, 3x. Now, we can't simplify this any further from here. So this is our single fraction. Yeah, it has a subtraction in the top, but it's still just a single fraction. Okay, this next one is factoring out a common factor. So if we look at the numbers 10 and 15, we can factor out a factor of 5. Both terms also have a y, so we'll factor out a 5y. Now that 5y needs to stay there. Then we open a parentheses and we divide each of these terms by 5y. So the y's divide out. 10 over 5 gives us 2, and that x is still there, so that's a 2x. 15 over 5 is 3, so plus 3. And now we have factored something out, and we can work on just simplifying what's inside the parentheses, which isn't as large as what you started with. Okay. On the next one, the next bullet here, talks about multiplying by a clever form of 1, multiplying by anything over itself. One thing we can do is multiply by what we call the conjugate of a denominator. The conjugate changes the sign in the middle. So this problem has a denominator of x plus y. We can multiply top and bottom by x minus y. Okay, and this will allow us to get squared terms in the denominator if that's what we need. Similar to what we would do if we had a square root in a denominator. Okay, so to work this out, consider each piece of the fraction in its own parentheses. Just double distribute or FOIL. So we will have 5x minus, that's actually going to be a plus x squared, then minus a 5y, then minus an xy. All of that will be over. If we go to the bottom and multiply this out, we get x squared plus xy minus xy plus minus, it's going to be a minus, that's a minus, sorry, minus y squared. In the denominator, when you multiply by a conjugate, you will always have those middle two terms dividing out. Okay, so in the top, you can rearrange the order if you need to. We don't really need to in this problem, but 5x plus x squared minus 5y minus xy, all of that's over. Our denominator is now just x squared minus y squared. Okay, now that can be very helpful with those Pythagorean identities. Can also be very helpful with difference of squares factoring if we needed to. And we'll see that here in just a minute. Okay, so look at the next one. Do any obvious algebra like distributing, squaring, or multiplying. So in this next example, we are squaring x minus 5. And remember, when we square a binomial like this, it's not just x squared plus 25. It's not even x squared minus 25. We have to multiply x minus 5 by itself. Okay, multiply that by itself. So x times x, x squared, minus a 5x, minus another 5x, minus times minus is plus 25. And now we do have these terms in the middle that will combine. They are both x's. So x squared minus 10x plus 25 would be our multiplied out solution there. Okay, make sure when you are squaring that you multiply it by itself. If you have a plus or minus inside that parentheses squared, it's going to be a little more challenging. Okay, let's look at a few things with exponent rules. Let's get that out of the way a little better. Okay, remember when we have a times a to the third, that is a to the first power. If you want to multiply or write that out, it's a power of a times 3 powers of a. So that ends up being a to the power of 4. Now, that is adding the exponents. A to the first times a to the third is a to the power of 4. Okay, if we do the same thing with those d's, d squared times d squared, that is d to the power of 4. We add the exponents. Now, some other things we can do here when there are squares of functions, think about the Pythagorean properties. Okay, also look at factoring, which is what this next one is going to look at. So we have 4x squared minus 25. That's 2 terms, and they are both perfect squares. So we can factor this as the difference of squares. Take the square root of 4x squared, that's our 2x. Take the square root of 25, that's where the 5 came from. Okay, and then when we factor this, that first term 2x goes at the front of each parentheses. That second term 5 goes at the end of each parentheses, and one of those is plus, one of those is minus. My brain will always put the plus first. It's totally okay if you put the minus first and then the plus. So don't forget about difference of squares. This can come up a lot with those Pythagorean identities. Now, a couple reminders from our previous lesson. Remember that sine squared theta plus cosine squared theta is equal to 1. That is our basic Pythagorean identity. Okay, and then 1 minus sine squared theta is equal to cosine squared theta. What we did here was subtract sine squared theta from both sides of that original identity. Okay, also 1 minus cosine squared theta is equal to sine squared theta. So those can help with sines and cosines, especially when you have squared terms. All right, y'all, that's it on this front page. The second page of this lesson is worked out on the other video file. Bye, y'all.